So we have to find the eigenvalues and eigenvectors of this, right? Okay, so what do I do for the eigenvalue? You keep talking. Look at the determinant, right? So which minus lambda you said, right? Okay.
I think it's lambda minus -2.
Actually, well, yeah, just 1 second. No, it's that minus lambda, and let me just tell you how to keep that in mind easily. See this here? Yeah. So see, you have this. What are you solving for, Sam? I mean, what do you need? You need the following. Oops.
I think it is 2 minus lambda.
It's negative 2. Okay, you agree, right? Okay, yeah, I'm right. Okay, good. All right. Well, but thanks for checking. Okay, so we got that right. So then, what we shall have? We shall have this, right?
2 minus lambda.
2 minus lambda. Very nice. Okay. Then minus. Then negative 5 times what?
1.
And that equals what? 0. Okay. All right. So this negative sign can be factored outside, right? See that here from the first one. So we have what? We got negative sign and then this. Okay, makes sense?
Yeah.
Okay, so what do you get? This guy would become 4 minus lambda square, right? Okay, this negative and this negative. I have a 0 here, divide by negative 1, they are common, right? Okay, and then I have what? Negative 5 equals 0. Is that negative 5, right?
It should be positive.
But remember, we divided by negative 1. We didn't show it, but we do this. Divide by what? Negative 1, right? So when you divide by negative 1, what do you get? You get the following, right? Makes sense?
Yes.
So now that makes sense, right, sir? So we get what? We get here we go. Okay. Like that, right? And then this will be what then? 4 minus 5 would be what? Simply negative 1, right? We divide by negative 1 again, right? Okay, so what happens is then, and then lambda will be what? Plus or minus I, right? Are we good? Here. So that's they are your eigen values, right? Now, when you are finding your eigenvectors, okay, what do you have to do in that case? You take this, right? Now, so if, say, you got this here, if this is an eigen vector, okay, for say corresponding to I, right? What do we get? We get the following. This has to equal I times, right? The same thing, right? Am I clear? Okay. Is it making sense? Good. So very good. So what we have then is this. If we multiply these here, okay, so we get negative 2x minus what, 5y, then x plus 2y equals ix plus iy, right? Makes sense? I here and I here, right?
Oh yeah, this only here, only on this.
Oh, I know what you mean. That I am cheating. I'm doing an easier one. I'll do, yeah, I'll do the one in which the real part is also non-zero. Okay. All right. So
this is more complex.
that it's complex anyway. Okay.
Right.
That's got real part to it. That's not more complex. It's got real complex, right? Is that good? See, that's what you get, right?
Right.
Okay. So what does it mean? This one means this. See this here. That let's bring ix to this side, and let's put x's on one side and the y's on the other. Is that good, scene? And then we have equals what? 5y, right? Let's look at this guy. So so in this case, what happens? We got this x equals negative 2y plus iy, right? And then x equals what? Negative 2 plus iy. All right? Are we good? Now, the thing is this, that these two, these two mean the same thing, all right? Whether I take x equals that or y equals this, let me just show you. Okay, just like in the real portion. So here you go. Say this here. What I'm trying to show you is, this and this are equivalent, right? So let's multiply here. Both happen here. I don't. Oh, I see. It's okay. I'm just. Where are we? We are going to multiply by this guy, right? Is that good?
This on how we, why we multiply.
Oh, I'm just saying. See, this equation is equivalent to this equation. They don't look this way, so I just want to show you that they are the same. Okay. All right. That is, either of them is going to give us the same thing, and if you have no problem with that, I will not show it to you. So which way you want to go?
So wondering how they are the same.
Okay, you wonder, right? So since you wonder, let's go ahead and get unwondered. Okay. All right. So here, what you have is that, see this here. If you multiply these together, you get negative 4 minus, you get negative 4 plus I squared, don't you? Right? Okay. Is that good? Okay. How much is I square? How much is it? I square is simply negative 1, isn't it? Right? Very nice.
That guy is a square root of negative 1.
Yes, sir. Okay. So negative 5, right? Negative of negative 5 is what?
5.
Very good. Thank you. So, and then 5s cancel. All right, don't they? So what happens? What do you get after 5s cancel? That. So they are the same equivalent, right? Just like we multiplied the other one by a non-zero number, right? Okay, good. So now we are going to write the solutions, right? And so, or before I go ahead and before we go ahead and look at this, then, so if I'm writing an eigenvector, what do I have? I have x, y, right? Okay, makes sense. So when I again have what instead of x, I can write this, right? Okay, so that, and then I have a y, right? So then I have a y here, and when I got I, O, and then 1. Is that good? I just factored a y out, right? Okay, yeah. Okay. So what do you get? So we get the following, that this is an eigenvector of who? Of who? Tell me. I. Right? So what will I have as a solution? E to the it, right? Times this, yeah, is a solution, right? Now, so this is a complex solution. What we will do is, the way you saw theoretically, is that we will go ahead, multiply it out, split it as real part and imaginary part, and they will give us two linearly independent solutions, right? Okay, good. So now this guy, e to the it by Euler's formula, okay, becomes what? Remember that? Yeah, this thing. Yes, this becomes what? Cosine of t, right? Plus I sine t, right? Doesn't it? You agree, right? Okay, good. Yeah. And you applied Maclaurin series, and you liked Maclaurin series, didn't you? Right? Okay, so here you go. So we have a happy bunch of people, huh? Yeah.
It's going to be well.
I know. It did to me too. That's okay. Right. So we got that here when we multiply them, right? Okay. And then this also becomes what? The same thing, right? Makes sense? Good. So upstairs we will go ahead and distribute, right? Okay. So we will have what? Negative 2 cosine t, right? Plus I cosine t, right? I'll hang on, sure. So what did we have? Negative 2 cosine t plus I cosine t minus 2I what? Sine t, then plus what? I square, right? And then what? Sine t, right? Are we good? So this is I. So this becomes what? Simply negative sine t, right? Okay. Is that good? Okay, sir. All right. So here we go. So we will do this. Let's bring this down here. All right. Okay. And here we will do what? We will factor I out. All right. See this here? Okay. Very good. So what does this thing become then? If you look at it, this is sum of what? Sum of This is my real part, right? Here. And cosine t right here, right? Then plus I. And then what we have?
T plus 2 sine t.
Good.
Sine t.
Very good. So what do we have? We have this. So this and this, right, are two, excuse me, linearly independent solutions of your differential equation, right? Are we good? Okay, so now let me show you the one in which you will have a real part also.
Action.
Okay. All right, so you can see this here. In this case, eigenvalues are these, right? And if you cancel that out, see the 2 will cancel, then 4, that 2 will cancel. That's what you will get from the work in your paper, right?
Okay. So this 4 would become a 2.
Right, so 2 will
cancel.
Okay.
But the 2 would cancel?
You're right, 2 will cancel. They will cancel, yes sir. Okay, negative 2 plus minus 2I over 2, factor a 2 out, you get the same thing, okay?
So I get like negative 1 plus or minus
I. And that's what is blinking up here, right? Okay. So now the thing is, you can do this like, if you apply the same procedure now to find the eigen vectors, you can go through a shortcut. Say you have a matrix like this, right? So you can go like A minus lambda, okay? Then leave this diagonal just like that, minus 3 minus what? Lambda, right? Okay, and then you solve for what? I mean, we are just abbreviating or just, putting those steps together in just one step. So you have this 0, 0, right? Okay, are we good? Okay, so same thing. So if you solve, this thing, that's what you will get. Okay, so here for lambda, I'm writing negative 1 plus I, negative 1 plus I, right? Okay, so when you do that, say, so I simplified it, it's 2 minus I and then negative 2 minus I, okay, and that's 0, 0. And see this here, when I solve it, I'll get these two equations, okay? And if you just go ahead and, you don't have to work it out, but it's good to check that these two mean the same thing, right? Okay, so now when I have x, y, I could write this in terms of y like this. So I got a y, y here, okay? So any multiple of that is an eigenvector of that, right? So this is a solution, right? Isn't it? Make sense? Okay. So this becomes this, and then what I have, I got this, right? So now we want to apply the Euler's formula, right? So we will do this, get negative t, and then get what? Ti, right? Again, makes sense? So what I have then is e to the, excuse me, here, negative t, right? And e to the ti becomes what again by Euler? Cosine t plus I sine t, right? Makes sense? And then I get that, right? Is that good? And then we will go again in the routine fashion, all right, and finish the problem. So would you be able to do that? Okay, yeah, because I got to go to the class. All right. Thank you, sir.